Hello and welcome to another rendition of our notes. I am your host, Miss Pranky.
And I'm your co-host, Mr. Harmson. So without further ado, let's get started with evidence for evolution. And yes, we're going to start off with Mr. Charles Darwin and how a lot of sciences actually help support his theory for evolution. So since Darwin, scientific tests from fields like geology, paleontology, chemistry, embryology, and molecular biology have supported his basic ideas about evolution.
Yes. So the first type of evidence that we're going to talk about is biogeography. This is going to be where organisms live now and where they have lived in the past.
And obviously, biogeography comes from the word that we're studying as life and then geographically where it's located and why it is adapted to those geographical regions.
Yes. So we are going to start with a very famous experiment. It was done by the Grants. Darwin also observed them on the Galapagos Islands, and these are the Galapagos finches. These finches left the mainland, and they are now separated from the original population due to an ocean. So these organisms are going to occupy open niches if they are available. So the finches evolved in isolation based off of the food and the resources available to them.
Perfect. Now we're going to transition to distantly related but similar organisms. And we're looking at ground-dwelling birds in Europe, Australia, and Africa. These do not have a common ancestor, but are similar due to selective pressures within their environment. So they kind of look similar, but they're not actually related.
Right, where the finches now evolved differently, but they're related because they have a common ancestor. The next type of evidence for evolution is fossils.
Here we're going to take a look at the age of the Earth. And we know that evolution takes time. And the Earth is about 4.5 billion years old, which is absolutely remarkable. And it's measured by radioactivity in rocks and fossils, which we learned about last week.
Right. So remember, we use radiometric dating in order to determine the age of rocks and fossils. And these are going to help us determine how old things are and where they fall in history.
Fossil finds. So fossils tell the story that traces the evolution of modern species from extinct ancestors.
Yeah. So if you look on the right here, this is a phylogenetic tree, which we will actually talk about later on in this unit. And you can read phylogenetic trees based on the different traits that have evolved. So if you see the pink little nodule here, it tells you different traits as they evolve throughout history. So you can see where they come up and how different organisms have evolved from their ancestors.
Comparing anatomy.
This is going to be the third type of evidence in order to support evolution. The first type of structure is called a homologous structure. Remember that prefix homo means same. So homologous structures are going to be the same structure, however, they serve a different function. So in this example, we are looking at the bones of a frog, an alligator, a chicken, a horse, and a fish. We can see that all 5 of these organisms have the same bones. However, we know that they use them all for different functions. A frog and a bird both use their legs or wings for different things. However, they have the same structure because they came from the same ancestor.
Now, analogous structures have a common function but a different structure. So if you take a look at the shark, the penguin, and the dolphin, we know that they're all used for similar purposes, but they do not come from a common ancestor. Obviously, the penguin is a bird, but it uses its wings to propel itself through water, right? Much like a shark and a dolphin does. But if you look at the structure of the bones, they're not similar in function at all.
Right. So this has to do with the selective pressures. These 3 organisms evolved to be highly equipped and able to swim in water. And clearly the most efficient way to do that is with these fins or flippers. So it's from their environment, not from their ancestor. The last one are called vestigial structures. These are going to be inherited from your ancestors, but they don't serve a purpose anymore. So first example is with us and our wisdom teeth. Our jaws and our heads have actually evolved to be smaller. So we no longer need these teeth. They're grinders. And so that is why we get rid of them, because we just don't have the room for them anymore and we don't use them. You also have the naked mole rat here. The naked mole rat has evolved to actually not use its sense of sight. So they have eyes, but they don't use them in order to see. So it's another vestigial structure. So what we need you guys to do now with these notes, please make sure you go through and answer all of the questions throughout the note sheet. We put them on there for checking of understanding, and then go ahead and submit it when you're done.
So we have biogeography.
Yes.
Homologous structures.
Analogous structures.
Analogous structures.
Yes.
And vestigial structures.
Yes. And fossils. Don't forget fossils.
Fossils as well. Thank you.
Thank you.